Hello everyone. Today we're gonna learn how to apply a supervised classification with the Landsat 9 data on the Earth Engine Cloud API. So we're gonna load Landsat 9 data. We're gonna apply scale factor and generate a training data, a training label because we're running a supervised classification. We're gonna use random forest algorithm, built-in Earth Engine algorithm, and we're gonna generate a predicted map based on our classification. We're gonna assess the accuracy of our classification, and finally, we're gonna export the classified image to our Google Drive. Let's get started. So the first thing is to load an image. In this case, we're gonna load Landsat 9 data. So we're gonna import the Landsat 9 image collection from the Earth Engine data catalog. And usually we need to filter by study area and also by timestamp. So in this case, we're gonna use, for this example, we're gonna use data from January to May 2022, and we're gonna use filter bound ROI. We're gonna spatially filter it or subset it by our study area. We have not created a region of interest yet. We'll be creating this soon. And the next thing is we're gonna filter the satellite image by cloud cover. In this case, we're gonna use 10% as our cloud filter. So we'll use cloud image that have cloud contamination less than 10%. So that's not gonna remove all the cloud, but it's fairly a fair collection of cloud-free image. And so the next step is to do scale factor, as always. Satellite images come as integers to save storage space. So usually they provide product owners provide information on scale factor and offset. So we're gonna use that to convert this to a floating point data. So we're gonna write a function which is apply scale factors, and we're gonna name our function apply scale factors, and then our input parameter in that function is image. So we're gonna, because we have two groups of bands, the optical and the thermal bands, we're gonna write a statement for each of these thermal and optical band combinations. So because they have different scale factor, so we're gonna use the optical bands conversion factor here, and then for the thermal bands conversion factor here, and then we return this converted image. We're gonna use add bands to combine those scale factored image here. And we have not applied this function yet. We're gonna do so here by applying rescale is equal to dataset. Dataset is our Landsat 9 image collection, and then we're gonna apply this scale factor here by using map. So what map is a built-in Earth Engine function that does apply a function through each image in the image collection, or that executes the function to each image in the image collection. So we're gonna so what this does is it will rescale, it will apply the rescale function to all image in that image collection. Okay, and then finally we're gonna generate because these are multiple images, so we're gonna use a median aggregation method to generate one single image. So all this, what this is doing, just loading the image, pre-processing the image before we run a classification. So another thing is before we do the classification or machine learning, we want to display that Landsat 9 image just to make sure if it's cloud free or there are issues, whatnot. So it's always good to visualize the data. So we're going to create a visualization parameter here, and we're gonna specify the different bands that we're gonna use: band 4, band 3, and band 2 of Landsat 9, and also the minimum and maximum spectral values. And we're gonna use map add layer to display the Landsat 9 data. So we call that this aggregated image. Visualization is our visualization parameter here, and also just a layer name here, Landsat. And then we're gonna adjust the center, the zoom level here. But if we execute this, nothing is gonna happen because we haven't yet created our region of interest. So today we're gonna create our study region here. For example, let's go here in East Africa. The source of the Blue Nile here around Lake Tana here. So I'll just create, or you can search Bahir Dar if you want. That way you're gonna have some similar outcome. So we're gonna create a region of interest here. We're gonna use the drawing tool on the Earth Engine, draw rectangle, and so I'm just gonna drag here, including the lake and Bahir Dar city. All right, so and we're gonna rename this as ROY, and that's about it. So that's our study region. And so yeah, we have region of interest now. So we can, if we execute our code, now it should look good, or it should process the image. All right, so what it does is, because it has multiple scenes, it's gonna generate a combination of 2 Landsat scenes. So that's okay. And so we haven't done the clipping. If we clip this, it's gonna be like this area. So for now, we just actually I can check and uncheck our study site here. I think it's better to clip it, so I'm gonna do clip by ROI. That way we're gonna see only a Landsat image for our study region. Excellent. So that's what I mean by that. So instead of having the entire scene, we're just gonna clip it by our study area. So this is our Landsat 9 data for before we ran the classification. So this is Bahir Dar city area, Lake Tana, some croplands and whatnot. Okay, so next step is actually to generate a training label. Okay, so the next step is to create our label for the classification or our training data. So we're gonna use water class, urban class, forest, crop, and barn. So let's just zoom in to our Landsat image here. Let's just change it to Google here. So for example here, let's see. Let's find some vegetation cover here. All right, so we found some, it's not dense tree cover here. I'm just gonna check if I could find dense tree cover. Okay, I think that's a wetland area. Probably, okay. So this would be a good training sample for vegetation or forest covers. So I'm gonna create a new layer here. I'll call it forest. And then instead of geometry, I'm gonna use a feature collection and add properties. I'll say class, and the value for the forest class would be 2. And then I'll just do color. Green color is okay. I think should be good. Probably deep green. Okay. All right. So when you want to capture the training data, you want to make sure that you highlight it here. That way, when you click, it's gonna capture the training samples. So every time oops, okay. So that's a mistake. Let's go ahead and delete this because we're gonna create a point instead of a polygon. So we have to click here. We have to click this point and then create a new layer. Okay, so we'll do the same forest feature collection, and then property class, and then 2, assign it to, and then install this green here. So it's highlighted here. I'm just uncheck this. So if it's highlighted, now it's highlighted here. So I'm gonna capture points instead of polygon. Should be fine. Now, every time I click, it should create a point, right? So you can see. So we're gonna digitize, capture as many training points as possible for the water class. For the forest class here. About 30 points should be fine here. So it's a pretty good. Ideally, you want to just capture in as many different locations as possible. But for this demonstration, I'll just capture about 30 points in this area. And then next sample is actually water class. So let's create a water class here. Water. And then again, a feature collection, and a property is, I'll say, class. That's our label. And then for water, I'll use 0. And then a blue color for water class. So I'll just, it's highlighted here. So I'll create a sample points for water. So this is a lake. So I'm gonna actually, instead of the Google background, I'll use the actual Landsat satellite image. So I'll create sample points here. All right, so yeah, so I have about 30 points, and then let's create an urban class. The next one is urban class. All right, urban, and then the feature collection, again, class, and then I'll use 1. That you can change. It's not it's just random numbers that I think make sense to me, but you can change the numbers if you want to. But don't forget, when you do the visualization, don't forget these numbers, what they mean. I'll just create some I'll do some red color here for urban class. So I'll highlight urban here. So I'll just go ahead and you can use the pan zoom to go to some urban area. So this is urban area, and you can see here. So I'll just go ahead and capture, or I'll have to highlight it first here, and then I'll capture some urban classes here. So these are built environment, buildings, residential areas, storage, industrial buildings and whatnot. So okay.
Sanford Kitey, wake up, it's 9 p.m.
Okay, so the next classification is a cropland. Let's create a cropland area. A crop here. Again, I'm gonna use the feature collection here. Class, and the class I would use 3, and then I'll use probably yellow color for cropland here. So I'm gonna go to the farmland area, cropland area. Just if you zoom in here, you can see all the farmland here in rural areas. So you can see all these farms. So I'll use crop here and then start capturing the training data. All these are, how do I know? Based on the pattern of this lands. All right, so this is there's crop here, the other ones are empty. So yeah, I'll just go ahead and generate cropland samples here, and over here let's just go to some different place here. We want to make sure that we're capturing it along the landside area. Okay, we're capturing here. Okay, so the last one is barn class. So let's create a barn class here. Barn. And then for barn class, I'll use 4. Oh, that's class. That's the name. 4 here. Probably I'll use a gray color or something like that. All right, so barn here. Let's find some barn area here. Okay, so some barn area. Looks like there's something here. Not a cropland, but just a barn area. Sometimes it's pretty confusing to differentiate, barn and cropland, but hopefully we can figure it out. This is not a cropland, but it's in terms of spectral signature. If there's no crop on the farm, so it's bare soil, right? So crop and barn area might be confusing, but if there's a cropland, if there's crop on the farm, then you can easily differentiate barn from cropland. So just careful on that one. So let's just generate some sample points over here. This is just for a demo purpose. If you're doing a really scientific analysis or a real project, the sampling approach has to be more careful than this. This is just for a simple demonstration purpose. Okay. All right, so we have all of our training points or label for our training. So the next step is now actually, let's just actually check our, so we have all of our training points. Let's just actually change the, so we have all the different classes. So now we have already created our training data for our classification, right? So all of the training data we've created, they are automatically imported here on our engine. So all of the classes here, right? So the next step is actually to to merge all of these, separate training points um, into a single point, a single database. Um, so we're gonna use, so I think let's just change the name. This is cups water capitalization. All right, so yeah, crop. Okay, so what we are doing is just we're merging all of this into a single table. So we just merge them, and that's it. We're gonna run that. So we have our training data ready. And then let's define a label. So label is our class. Remember, we stored all of these integers 1, 0 up to 4 for each of the land cover classes. So that's our class, the label for the classification. So the bands, these are the independent variables for our supervised classification. These are the Landsat bands. Okay, we're gonna use that. So our input would be the Landsat bands, but only these, this band 1 up to 7. So we're not gonna use all of the Landsat bands, but only these specifically selected bands. Okay. And next thing is to actually prepare. So now what we have done is we have our Landsat image, we have our label class, and long information, and also the class. But the next step is we're gonna extract Landsat values for each of these point locations. Okay, so that's what the next function is doing. So we'll use a sample regions to combine the Landsat data with our training data. So our training here. So we're gonna create our training, combine the Landsat image with the training labels using sample regions here. So this is a dictionary that has 3 parameters. The first one is a collection, the training label that we have created here. And then the next one is the label, which is, the class, right? That's technically the land cover class labels, and the spatial resolution 30 here. So we can go ahead and print that here. All right, so let's go ahead and print that here. So technically now we have our training data combining the Landsat image, the Landsat bands, with the land cover class. So we can run machine learning classification using this table. So we're gonna feed this to, we're gonna train the model using this training data, okay? Okay, so next is to actually, because we're gonna use withheld some of the data for evaluation purpose, we're gonna split the data to training and validation data. We're gonna create a random column, and then split the data 80% and 20%. This is what's gonna split the data. The next step is actually to train the model, and so we're gonna do that by training the model using the random forest classification here. So we'll be using a SMILE random forest. That's an Earth Engine built-in classifier. And this requires parameters. First one is feature set, so that's our training set. So that's what we're gonna use 80% of the data to train this model, this supervised classification random forest model. And a class property is a label. You remember the class here? That's our class label here. That stores the different land cover classes, okay? And the last one is input properties. That's the independent variables, the Landsat bands. So once you provide this, it will generate, it will train the model, the machine learning model here, based on the table. So the next step is actually, now we have trained our model. Let's go ahead and then apply the classification. So what it does is it will generate a prediction, a predicted land cover based on the Landsat input image. So this is a table. Now it's gonna convert the Landsat band into predicted land cover classification. Okay. The next step is actually to visualize our land cover classification. So let's create a land cover palette here for each of the classes. For example, water, urban, forest, crop. We're gonna give different colors here. This is our list, stores the visualization. So we have a classified image here, the land cover classification. We're gonna clip it by our region of interest here, and then provide a color palette here, the land cover palette here, and min max is just different land cover classes from 0 to 4, remember, and then the layer name here. That is it, and we're gonna see hopefully land cover classification on our map canvas here. Let's just remove the Landsat image. Let's remove the training data sets here, or label here, that way. So now we have a land cover classification, a predicted land cover classification based on our training data and also the Landsat band. So you can see that we have, mind you, we have only about 30 data points, generated. So it's not really a thorough sampling, but we did a good job in terms of really identifying the different land cover classes. As you can see here, this is a forest area. We have identified it as forest, and water, much easy class, and croplands, as you can see here. So this is just an example of how you can perform land cover classification using machine learning and cloud computing Earth Engine, and manually generating a training data, your own training data. So the last step is actually to perform accuracy assessment, and we're gonna use this to evaluate the performance of our classification. So we're gonna use EE confusion matrix. So in this case, we're gonna use the evaluation data. You remember, test set data, 20% of the data we saved for evaluation. That's what we're gonna use here. So we're gonna use this function, and so the actual is class. That's the actual. That means the training data label, right? So the classification is the predicted class, and class is the training class. So we're gonna use these two based on the predicted as well as the training data, and then we're gonna generate overall accuracy assessment, producer user accuracy, and also confusion matrix. Let's go ahead and execute our accuracy. So overall, it's interesting. We have about 100% accuracy, and that's pretty interesting. And then in terms of exporting the data, we can, and mind you, the confusion matrix here, we've done only 30 data points, so it's it would be overfitting. So I would, for a real project or scientific analysis, I would create more training samples, and definitely the overall accuracy would be not 100% in that situation. So I think the final step is to export our data, and then to Google Drive, like the classification, the map, so that we can either visualize it in other softwares like a GI software. So we're going to use export image to drive, and we're going to provide that classified image, and then we're going to have a description, Landsat, classified RF, or you can name it differently. The spatial resolution 30 meter, and our region of interest, already the box here. And when you execute that, it would export that to your Google Drive. And that's how you can perform supervised classification or random forest classification based on Landsat data and your own training labels.